In section 3 here, we're going to look at solving linear systems using elimination now. So we've already discussed two methods, graphing and substitution, and now we're going to go ahead and expand on that and look at using elimination. So recall that when you're solving systems, the solution is the point x comma y, which satisfies both equations, and it's the intersection of the two lines. Let's just review. So it says solve the linear systems using the elimination method. So remember, substitution, you'd have to pick one equation, get a variable by itself, and then plug that into the other equation to solve for the variables. In this particular section, all we're going to do is we're going to look at these two equations together, and we're going to say, okay, so I look at this, and I realize that if I just take these two equations and simply add them together, then my y's, because this is positive 5 and this is negative 5, are going to cancel. So x plus 4x is 5x. Positive 5y plus negative 5y becomes 0y, so those just cancel. And that equals 9 plus negative 14, which is negative 5. And so now from there I just divide both sides by 5, and I get that x equals negative 1. And then I will use that, I'll plug that back into one of my original equations here to solve for y. It won't matter which one. I'll plug it into the first one, so when I plug it in here I get negative 1 plus 5y equals 9. Add 1 to both sides. So you get 5y equals 10, which means that y equals 2. So your solution would be negative 1, comma 2. Okay? Again, the reason it's called elimination is because when I added these two, it eliminated the y variable. And so that's all you're looking to do is, can I add or subtract these two equations to eliminate one of my variables? Okay, example 2, I see I have 3x and 3x, and so the way I can cancel those out is by subtracting now the two equations, because 3x minus 3x is 0x, so those cancel. Negative 4y minus 2y is negative 6y, and 2 minus 26 is negative 24. And so now I just divide both sides by negative 6. That tells me that y equals positive 4. From there, I use that, I plug it back into one of my original equations. So I have 3x minus 4 times 4 equals 2. So I got to add 16 to both sides. So I get 3x equals 18. Divide by 3, x equals 6. And so your final answer here is the point 6 comma 4. That would be your solution. So again, do I have to add or subtract in order to eliminate a variable? In example 3, I see negative 8x and positive 8x, so in order to get those to go away, I have to add them. So negative 8x plus 8x is 0. And then I have 3y plus negative 9y, that's negative 6y, equals 12 plus 12, which is 24. Now I divide both sides by negative 6, which tells me y equals negative 4. And again, now I'm back to square one, just plug it in and solve for x. So 8x minus 9 times negative 4 equals 12. I plugged it into the second equation. So 8x, negative 9 and negative 4 makes a positive 36. So I'm subtracting 36 from both sides. And so I get 8x equals negative 24. Divide both sides by 8 means x equals negative 3. So the solution would be negative 3 comma negative 4. So again, just eliminating. Add or subtract your two equations to eliminate a variable. In example 4, I see 6y and 6y. So if I want to get rid of those, I have to subtract the two equations. So I have x minus negative 2, so that really means x plus 2x, which is 3x. 6y minus 6y, 0. And then 13 minus negative 8, which really means 13 plus 8 is 21. Divide both sides by 3, x equals 7. And so now I go back and I plug it in. Negative 2 times 7 plus 6y equals negative 8. This is negative 14. Plus 6y equals negative 8. So I'm going to add 14 to both sides. So I get 6y equals 6. Divide both sides by 6, y equals 1. So 7 comma 1 is the solution here. And again, I would get in the habit of mentally checking these things. So I go to the first equation, 7 plus 6 times 1 is 6 equals 13. Check, that makes sense. Negative 2 times 7 is negative 14. Plus 6 times 1 is 6 equals negative 8. That makes sense as well. So that's the nice thing about solving systems, is you always know if you're right or not. Now you'll notice here in the second one, what you need to do if you want to use elimination is you need your equations to be written in the same form. In other words, if you have your x, then your y, then your number, like we do in this first one, right? X plus y equals a constant. Well, then I need to rearrange the second equation to have the same format. So the first thing I'm going to do here is I'm going to subtract 6x from both sides. And so what you end up with here is you end up with negative 6x plus y equals negative 32. Okay, and now all I'm going to do is rewrite this guy down here. So I'm going to bring that one down, and I have 6x plus 7y equals 16. So these two equations here are now the two that I'm working with. So I see 6x and negative 6x. So to get those to cancel, I just have to add. So negative 6x plus 6x is 0. Y plus 7y is 8y, and negative 32 plus 16 is negative 16. Divide both sides by 8, y equals negative 2. And then I'm going to plug that back in to either one of my original equations. Okay, so I have 6x plus 7 times 2 equals 16. So I got to subtract 14 from both sides. So 6x equals 2. Divide by 6, x equals 1/3. And so your final solution here would be 1 over 3, comma, negative 2. So hopefully this is starting to kind of click a little bit as far as using the elimination method. Okay, a story problem here. Again, you're going to have to come up with the system on your own. So it says the students in the graduating classes at 3 high schools in a school district have to pay for their cap and gowns. A cap and gown set costs X dollars, and an extra tassel costs Y dollars. At one high school, students pay $3,262 for 215 cap and gown sets and 72 extra tassels. At another high school, the students pay $3,346 for 221 cap and gown sets and 72 extra tassels. How much will students at the third high school pay for 218 cap and gown sets and 56 extra tassels? So, a lot of words going on here, obviously, but long story short, what you need to do is you need to set up a system. So cap and gowns cost X dollars, extra tassels cost Y. So in the first high school, I know that if I take 215 times X and add to that 72 tassels times Y dollars, that's got to equal 3262. If I look at the second high school, I know that 221 cap and gowns are bought, and 72 tassels are bought, and I know that that's got to add up to 3346. And so I think you'll hopefully recognize here that I can solve this system pretty easily by just subtracting the top one from the bottom one, or bottom from top, whatever. So 215x minus 221x is negative 6x. 72's cancel, and so negative 6x equals, I have 3262. So 3262 minus 3346, and that's negative 84. Divide both sides by negative 6, so x equals 14. Okay, so in other words, what that means is cap and gown sets cost $14, and now to find tassels, I'm going to plug it back in. I'll just plug it back in here to the first equation. So I have 215 times $14 plus 72 times Y dollars equals 3262. So what this is, I got to do 215 times 14. That's 3010. So I'm going to subtract 3010 from 3262. So I end up with excuse me, 72Y equals 252. Divide both sides by 72, which tells you that the cost for tassels are $3.50 each. And so now to answer the final question, it says, how much will students at the third high school pay for 218 cap and gown sets and 56 extra tassels? So I know I have to do 218 times 14 plus 56 tassels times 350 each. And I just simplify that down. So 218 times 14 plus, so that's let's see here, that's 3,052 plus, and then I have 56 times 350, which is 196. And so when I add those two together, I get, let's see here, 3052, $3,248 is how much that school is going to spend. So you'll notice it's quite an extensive problem in terms of setting up your system, solving your system using elimination, and then using the information that you've gained to actually answer a third question. So hopefully that did a nice job of kind of summarizing this section on solving linear systems using elimination. As always, bring any questions to class and we'll go from there.